So Professor Liu is going to teach you the multiple choices. We're going to review them, use multiple choice as review. So I click on that. And I'm going to click on the questions. All right, so remember you and I have the same question but different order. Okay, so let's do it right now. Let me make this a little bigger. All right, so let me start it. Okay, so the first question say the advantage of the linear search is that, and it is simple, and it is simple, and it can be used on older data. So that's is so 95% of your thing is that simple, and the data don't need to be searched, don't need to be sorted. Uh, what sort is more efficiency for this? All right, so of course the binary search is more efficiency than linear sort. Okay, there's a string double, those are fake thing. All right, then we are going to do this. So the linear search is adequate for searching through what kind of array? Not enough small array. Small array fine, large just don't do linear search. That makes sense. Is that right? And let's continue to do this. All right, so a binary search. A binary search begins by exam. Remember, binary means half. Exam the middle element of the array. Is that right? The binary search, we already told you, cut to half and check the middle. If you are so lucky, the middle one is that, and you got it. Okay. All right. So, um, if uh, if a term being searched for is not in the array, so binary search stop looking for it and report that it is not there when this uh, when your array index first uh, greater than your array last. Let me see. Correct word. Search for is not okay. So once you do that, then you will stop. Next one. All right. A search can be performed on an array of all integer arrays, string array, object, all of these. Okay, all of these. That's why it's important. Okay. And next thing we talk about a sorting algorithm. A sorting algorithm can be used to arrange a set of number in ascending order, descending order, a string ascending, descending, all of these. All right. So you really can you decide you want to be ascending order or descending order. All right. Then let's continue right here. What kind of sort usually perform fewer exchange than the other sort? Is selection sort usually perform fewer exchange than bubble sort? Now for this chapter, we only cover the bubble sort and selection sort. There are many others in your study by yourself. Okay. And let's continue right here. So to find value, that is an unordered array and a 100 item only. Linear search must examine and average how many value. Linear search. All right. So linear search here, because you have to think for this. Okay. When you are lucky, the first one is get it. Is that right? So 1. If you are not lucky, you search all the way to the end. That's 100. All right. So is 0. So 0 plus 100 divided by 2 is 50. Do you understand this average mean? It's not sorted, right? So you just need to try the luck, right? And you're lucky, the first one got it. No search. If you're not lucky, you search all the way to the end. So that's 50. You understand this or not? All right. So let's continue. Next. All right. So I want to determine the item is to determine that the item is not in an unordered array of 100. So linear search must examine the average of 100. All right. So it's not to determine the item is not in an unordered of 100. All right, so if we want to determine this is not inside that, so basically you need to search for every one of them until that's 100 times. All right, so we'll continue right here. To locate a number in an ordered array. So this time is ordered array right now. They are ordered, okay? The binary search at most 7, because there's a formula right here, is the formula is let me look for the formula for you, and you'll find I have a formula for you, okay? So say, can anyone check the binary array? Binary array, there's a searching formula, okay? And let's take a look here right now. And if a binary sort is used to arrange 7, 5, 3, 9, 2, 6 in ascending order, we're going to use bubble sort in ascending order. So 7 in a bubble sort, right? So we are going to ascending order, so you're going to take the largest one. Your bubble sort take the largest one. Which one is the largest one? 9. So 9 goes to here. All right. Depending on you want to ascending or descending, right? Ascending, take a 9 to the last one. All right. So let's continue right here. Let's do selection sort right now. Selection sort. And 7, 5, 3, 9, 2, 6. So ascending to the smallest one. Is that right? To the smallest one. So as soon as you find out smallest one as 2, you understand? You find out smallest one is 2. But you're going to make a 2 to here, 7 to here. Do you see a difference? Do you see a difference right here? All right. So you find the smallest one is 2, right? But then you're going to make a 2 goes to here, but 7 goes here. So 2, 5, 3, 9, 7, 6. Understand the difference? So that means when you do selection sort, you are replacing two number at one time. Bubble sort only one number, okay? When sorting an array of object, we're talking of object right now. So if the value in the data member being sorted on are out of order for two objects, it is necessary to swap the entire two objects. Okay. And let's continue to do this one. All right. So we can measure the complexity of an algorithm that solves a computational problem by determining the number of a number of basic steps it requires for an input of size n. Okay, so now anybody who find out to get a selection sort, to get binary search the algorithm. No, we'll find out that later. Okay, so this is your multiple choice chapter 9.